Hi students, for today's lesson we are going to solve simultaneous equations. So by the end of this presentation, you should be able to solve a pair of simultaneous equations with one linear and one nonlinear equation. But before we get into that, let us revise solving simple equations. So looking on this equation, 7h minus 3 is equal to 19. Now to solve an equation is to find the value of the variable. Now the variable here is h, and h is being multiplied by 7, then 3 is subtracted, and the answer is 19. So we need to get that h by itself. So first remove the 3, then remove the 7, and h would be equal to 22 out of 7. Solving another simple equation, but within this we have brackets. So now we need to simplify, then solve. So first remove the brackets. Then you're going to group your like terms and then find the solution. Now we're going to revise solving quadratic equations. So this equation is m squared minus 21 is equal to 4. So for this, we simply get rid of the negative 21. The opposite of minus 21 is plus 21. Add 21 to both sides. Then you'll find the square root of 25. So the answer there is negative 5 and positive 5. Looking on another quadratic, we have 3a squared plus 13a is equal to negative 4. So for this one, we are going to factorize the quadratic first, and then we are going to simplify. So a would be equal to negative 4, and a will also be equal to negative 1/3. So the two answers for a is equal to negative 4, and a is also equal to negative 1/3. We're going to look on another example. Now with this equation is 2m squared minus 7m plus 3. And we're going to solve it using the formula. So first we need to identify what is a, what is b, and what is c. And then substitute in this formula. So we have done our substitution. And we're going to simplify. Then we're going to split. So we have m is equal to 3 and m is also equal to 1/2. So here we're going to solve a pair of simultaneous equations, one linear, one nonlinear. So we have our two equations. You are going to label them equation 1 and equation 2. Now you notice that equation 2 is a linear equation and equation 1 is nonlinear because it has x squared. Now first take equation 1. You're going to make y the subject of the formula. We are going to do the same for equation 2. Make y the subject of the formula. We do this because both y's have a coefficient of 1. In the first, y have a coefficient of positive 1, and in the second equation, y has a coefficient of negative 1. So we know that y is equal to y. Then we're going to equate both of these. And then we're going to simplify, then solve for y. So I have used the formula method to solve for the values of x. And then what we got, we substitute in y equal to 2x minus 30, and we have found the values for y. So x has 2 values and y has 2 values. So at the end there is the solution for x and also y. Looking at another example, y squared is equal to x equal 5, and 2x minus y is equal to negative 7. Identify equation 1, identify equation 2. Looking at equation 1, we can make x the subject of the formula, and then we are going to substitute x in equation 2. So wherever x is in equation 2, we're going to substitute y squared minus 5. Simplify, and we have that quadratic equation. Then you're going to solve that quadratic equation, whether by the factorization method or the formula method. So y is equal to negative 1 and y is equal to 3/2. Then you are going to find the corresponding value for x. So that is one pair of solution, and this is another pair of solution. So this is your activity to complete. You are going to find the value for x and also y in both of these equations.